Good morning, good evening, good afternoon. Welcome back to the channel. This is Math with Mr. Leo. Today, we're going to look at the subject of slope. This was a request from a viewer. They left a comment. I appreciate you reaching out, and I hope you get something from this video. Slope can be a very confusing topic. It appears in several different places throughout math and has many different ways that it looks. What I'm going to try to do here is bring everything together and help you get a good understanding for what is slope and what are all the different ways you will see it. Now, before we dive into some definitions, I'd like to just begin with a problem. This is a test question. This could be on the GED test or something similar. And I just want to take a look at this as an entry point into the subject. All right, here's the question. Water pours into a tank over a 10-minute period. The graphed function f of x models the flow rate in gallons per minute, GPM. All right, we've got some vocabulary, f of x. For right now, you don't need to worry about that too much. What that's doing is describing this overall graph, as well as giving some names to the output of the graph. But let's just look at the picture here. Water is pouring into a tank over a 10-minute period. I see time in minutes from, this would be 0 to 10. And this function models the flow rate in gallons per minute. We see that on the left of the graph, flow rate, it looks like it starts at 0, then 10, 20, 30, all the way up to 60. We can think of flow rate as also like water pressure. You know, if you turn on the water in a sink, does it come out slowly or does it burst out and splash all over you? You know, a nice sink, you should have a nice smooth adjustment for that. All right, so we're looking here at a tank, the flow rate. The question is, over which of these intervals does the flow rate increase by the greatest amount? We've got some options here. Notice these are intervals, so you could choose when x is 0 to x is 1. Well, notice the x's, that is the x-axis, that's essentially time. All of these answer choices refer to time. So from minute 0 to minute 1, that's this first section. Minute 2 to minute 3, that's over here. 4 to 5, that's this section. And 8 to 9, this section. We're looking for the flow rate increasing by the greatest amount. Now, before we jump in and actually answer the question, here's a general thing I like to do. Every time you see a graph, try to understand what story is the graph telling. Every graph tells a story. Take a look here. What's the story? Well, I would say that this water tank, it's starting, the water is flowing at 40 gallons per minute. Over a couple minutes, that flow rate increases, the water pressure increases, and it's pumping water at that point 50 gallons per minute. That goes on for a minute. Then the flow rate decreases. It's coming down. It's slowing down, less and less water until we hit minute 8. And then it evens out and just stays consistent at a flow rate of 20. It starts at 40. It increases. It stays up there for a minute. Then it decreases. And then it stays at 20 to close it out. That's the story. So, what's the answer? Over which interval does the flow rate increase by the greatest amount? Now, did you make the very smart mistake of selecting answer choice B? B is not the answer. This is not the answer. People often think it is. Well, they'd say, Mr. Leo, look, from 2 to 3 minutes, that's right here. That's obviously the peak of the graph. That's the highest point on the graph. That's when the flow rate is at the highest. And you're absolutely right. Yes, that is the highest flow rate seen on the graph. But here's the catch. Here's the catch. From minute 2 to minute 3, how does the flow rate change? From minute 2 to minute 3, how does it change? It's not changing. It's staying the same. At minute 2, it was at 50. At minute 3, it's still at 50. Therefore, the flow rate in this interval does not increase at all. This increases by 0, by nothing. It stays the same. When does the flow rate increase by the greatest amount? That is this first section of the graph right here. When is it increasing? When it's going up. When the flow rate is increasing. When the line is going up. You could say this is from minute 0 to 1 or 0 to 2. Any of those answers would be good. The only thing here that fits that is A. This is the correct answer. From minute 0 to minute 1, it increases by the greatest amount. You could have also said 1 to 2. If they had 1 to 2 here as an option also, I would have a problem with that. It's both of those things. It's this entire section from 0 to 2. But given these choices, A is the only one that fits from 0 to 1. That's the answer. It's a great test question. I love questions like this. They make you think. Notice we did not do any calculations. I did not use a calculator. I didn't even write anything out. But why are we talking about this today? Because we're talking about slope. I could rephrase this as which interval has the greatest slope? This is essentially what the question's asking. It's not up here. That's a slope of 0. That flat line is a slope of 0. It's not sloping at all. The slope is right here. This is the highest slope. That is the only positive slope, meaning it's the only slope that's increasing. This is the only time the graph increases. It increases, that's a positive slope. Then it flattens out, that's a slope of 0. This declining section, this part that's going down, is a negative slope going down, decreasing. And then once again, it has a slope of 0 again. This is essentially about slope. When does the rate increase by the most? When the slope is going up. Okay, any questions about that? Leave a comment down below. Now, let's look at another question to lead us into this topic of slope. Okay, here's another sample test question that you might find on the GED or something similar. This is about functions. A company uses the function c of x equals 0.2x plus 3 to calculate shipping costs. This is our function. C of x is the total cost in dollars to ship an envelope. X is the weight of the envelope in ounces. So let's just look at that again. X is the weight. X is the weight. That's right here. This part is the weight, the X here. And C of X is the total cost. You might wonder, why do they use these letters? Why is it this way? That's sort of a subject for another video, but I will tell you very briefly. F of X is often used to mean the output of a function. F being for function, it's always kind of a fancy F. In this case, instead of using F, they're using the letter C to reflect cost. But they're still keeping this format of C of X, C onto X. We're not actually going to do any math right there. That's a label. In this context, C of X is just a label. It stands for cost. This X over here is the weight. That's the X we're going to worry about. So here's the question. What are the values 0.2 and 3 represent in the function? So this is really asking, can you read the function? The way I think about it is this. The 0.2 is going to multiply with the x. It's going to multiply with the weight. And then we're going to add 3. If the weight is a large number, 0.2 is going to multiply with that large number. It's going to multiply. It's going to be bigger. You could think of it as happening repeatedly. If x is 20, you're going to see 0.2. It's going to have to be multiplied by 20. It's going to happen 20 times. The 3, no matter what, it's just plus 3. We call that a constant. It's just going to always be 3. I don't care how much the weight is. This 3 is 3. It does not go up. It is not multiplied. It is not duplicated or replicated. The 0.2, though, that can happen repeatedly. So coming down here, we've got some options here. Did you take a look yet? The idea here is to understand both of those. I want the 3 to happen one time and the 0.2 to happen repeatedly. You might notice that the 0.2 could represent 20 cents. That's correct. So first off, A and B are wrong. We're not taking these answers. The cost to ship a 3-ounce envelope is 20 cents. That's not what this is saying. That's not at all what this is saying. This is 20 cents times something plus 3. And then this is the reverse, also wrong. The cost to ship a 0.2-ounce envelope is $3. That's not it. So really it's C or D. And if you've been following what I've been saying, you'll notice that it's actually D. D is the answer. The cost to ship an envelope is $3. That's happening one time plus 20 cents per ounce. Don't be fooled. Don't pick C because, oh, Mr. Leo, 0.2 comes first and then the 3. So I picked the answer choice that had the 0.20 and then the 3. No. I mean, that's true, but that's not why it's the answer. That's not the answer. Okay? Just because something comes in one order over here does not mean it's going to be the same order over there. We need to grasp the meaning. And the meaning here is $3 is just a flat rate. It's going to be $3 no matter what to ship an envelope, plus 20 cents per ounce. That's this concept right here, the 0.2x. That's 20 cents for every ounce. If you got 10 ounces, it's 20 cents times 10 ounces. You got 50 ounces, it's 20 cents times 50. The number with the variable that's going to be multiplied, that happens repeatedly. The number that's sitting there by itself, that plus 3, that's one time only. Therefore, the answer is D. I'll do a more thorough unit on functions later on where we'll talk about this a lot. Although today, we're going to dabble with it quite a bit as we discuss slope. All right. Why am I talking about this with slope? Because do you know what the slope of this function is? The slope of the graph, I would say the graph of this function, because every function could be graphed, the slope is 0.2 or 20 cents, however you want to think about it, but it's 0.2. This is the slope. If we were to graph this function, if we were to make a graph of it, you would normally put the input along the bottom, literally the x on the x-axis, that would be weight. And on the y-axis, the output, you would put cost. Can you see me drawing down here? Now here's the idea. Even if you want to ship an empty envelope, this place is going to charge you $3. If you want to ship an empty envelope, they're still going to charge you $3. And then what happens? Well, for every ounce, it's going to be 20 cents more. So imagine this is going 1, 2, 3, and so on. For every additional ounce, the price is going to go up 20 cents. And you would get a graph that looks sort of like this. It starts at $3 because that's the cost. Even if X was 0, this would still be $3. And then it goes up 20 cents every time. By the way, you got your notebook? Have you been writing things down? Now's a great time to grab your notebook if you have not already. You can go ahead and pause the video. I'm not going anywhere. Pause the video, and I want you writing this stuff down. Okay, are you back? You ready to write stuff down? Be an active learner, guys. Take control of your education. Here's the idea. This is going up 20 cents every ounce, right? We would say the rate of change is 0.20 per ounce. I'll write it that way. The rate of change is 0.20 per ounce. Therefore, the slope is 0.20. The rate of change is the slope. Write this down. The rate of change is the slope. You know what else is the slope? The slope is the multiplier. And this is a deep concept. We're going to be looking at this all day today. The slope is the multiplier. This function has a multiplier of 0.2. I'm telling you right now, that means the slope is 0.2. That corresponds to the graph here because this graph, we would say, is going up 0.2 for every click forward. For every additional ounce, as it moves to the right, it's going up 20 cents for every additional ounce. Up 20 cents, up 20 cents, up 20 cents. If you're familiar with the concept rise over run, this is 20 cents rising for every run of 1 ounce. We'll be studying that shortly. Come along for the ride. I hope you're taking some notes on this. Please make sure you have your notebook once again, and we'll probably use a calculator a little bit later on. So as we're here, we're going to have to discuss the basics of linear functions. Here's some basic ideas. A linear function makes a straight line. When they say linear in math, that means straight line. If it's curving, that's not linear. Linear functions never include exponents or roots. Those would be exponential functions. Those are curving functions. Those are also quadratic functions. Quad meaning 4 sides, meaning square, meaning squared, meaning second power, meaning exponent. Quadratic means exponents, and it's going to be curved. We're not doing that today. We're talking linear, straight. All linear functions fit this general structure of y equals mx plus b. The function we just looked at could be written as this: y equals 0.2x plus 3. That's the shipping function we just looked at. Of course, we saw it written with this slightly different terminology, c of x, but you'll notice the structure is identical. This is all about the language of math and really grasping the meaning. Look at these two functions that I wrote just here. Can you see how they are the same? The only thing different is the label. This is labeled y. That's a generic letter for the output. This is labeled c of x, meaning the cost being applied to the function. You'll notice here, though, the multiplier in both cases is 0.2. That's also known as the slope. Plus 3 is the same, that's the constant. So looking down here, x is the input in this famous version, y equals mx plus b. This is the generalized structure of a function. X is the input, it goes inside the function. Y is the output, it sits out here by itself. You do all the math on the right side first. I know that might be weird, just go with it. You do the math on the right side, which gives you the result y, the output. Very important, m is the slope. M is the slope. M stands for multiplier. That's how I look at it. Write this down. M is the multiplier. I've heard actually from someone, though I think we looked it up, that M actually comes from montrere, which is the French word for mountain. Mountain being like a slope, right? Like a ski slope, mountain slope. So montrere, mountain, M, slope. So that's actually what I've heard. It's like Latin or French. M, montrere, slope. But works just as well to say M is the multiplier. The slope is the multiplier. Write that down again. And lastly, we have B is the y-intercept, also known as the starting amount, also known as the constant. In this case, that starting amount was $3, right? To mail the empty envelope was $3 plus 20 cents per ounce. This is the function of all linear functions. They often come already right here in this format. Sometimes they'll give you a hard one that will be in a different format, and it will be up to you to kind of rearrange it. We're not doing that today. Just come along for the ride. Slope is the multiplier. Let's move on. This page is basically the same information. I just want to review it again from a slightly different perspective, reviewing what we know, the parts of a linear function equation. Here it is again. Here is a linear function. Please notice this perfectly fits the format, y equals mx plus b. That's the generic format. This is specific, f of x equals 3x plus 4. You'll see here that f of x, that's labeled as the output. Sometimes they call that the dependent variable because the output depends on the input. The output is the dependent variable because it depends on the input. The cost to mail the letter depends on the weight of the letter. Therefore, the cost is the dependent variable. You can also say f of x is the function of x. That's why we use the letter f here. And then we have y is the same thing as f of x. You'll often see this just as the letter y, or you'll see f for f of x. I've also seen sometimes g of x and h of x. Don't let these confuse you. This is them going alphabetically from f. Sometimes f is already taken, so they'd say, well, what's the next letter in the alphabet? F, G, H, I. So if they've already done a f of x, maybe they'll go g of x next. It's just a label, meaning it's the output. And of course, we saw the previous example was c of x. They used the letter c there to refer to cost, to refer to something specific for the question. Okay, all of that is the output. This is the language of math. Boom, here's what we're looking at today, the multiplier. In this case, it's 3. That is the rate of change. That is the slope of the line. If this was a different shipping function, we would say this is $3 for every ounce, plus the flat rate for, in this case, they call the starting amount or the y-intercept. That would be the flat rate. And then, of course, the letter x is the input. By the way, we call that the independent variable. It's because it just is what it is. If you're going to mail a letter, the weight is just whatever the weight is. It's independent, but the cost depends on the weight. You can also just remember input, independent, in. Okay. So look at this one down here. Tell me right now, here's a function. What's the slope of the graph of this function? Function at the bottom of the page. What is its slope? The slope is 5. Why? Because 5 is the multiplier. That's it. That's it. Now, we're going to have to do more math. You will see this in other places. We're not done, but this is a very good starting point. Slope is the multiplier. All right. Make sure you've got some good notes on this before moving on. Feel free to pause the video and write this stuff down. Let's move on. All right. Here we have a function rule. F of x equals 2x plus 3. We've got a blank data table. We could fill this in ourselves. And here I have the graph. So I've given you the graph of the function. Now right away, look at these notes here. I'm telling you the slope is 2. How do we know that the slope is 2? Well, first off, since we have the rule, you can see the multiplier is 2. If you have the rule like that, you get your answer so fast. The slope is 2. But now let's look at the graph. What does it mean that the slope is 2? Well, first off, acknowledge that 2 is a positive number. If the slope is positive, that means the line is increasing. And you always read a graph from left to right. Write that down. Always read a graph from left to right. Always. So from left to right, we would see the line is going up. It's positive. But how is it going up? In what way is it going up? This is the visual method. And if you look really closely, try to pick some points that are very clear. I like to start at the beginning if you can. I think these are mostly whole numbers, so it's going to be easy to see. You see right here, it starts at 3. And then as this input moves forward, 1 click. As it moves to the right, 1 click. Where's the next output? And you can see it's moved from 3 up to 5. That's an increase of 2. As it moves ahead another click, you'll see it moves up by 2. And you'll see that's the pattern for this linear straight line. It's moving up by 2 every click. Therefore, the slope is 2. It's increasing by 2. There's a visual method here that some people might have learned called rise over run. This is a visual way that relies on you counting. We could apply that here. It's kind of going to summarize what we just did, but let's just check it out. So from this point, let's say to this point, how much does it rise? Now, from this point, this first point, to get to this one, it's going to have to move up and to the right. Up and right. Now, you want to say, how much does it have to move up? Well, it would have to move up 2 clicks. That would get us here, and then it would move right 1 click. So it's up 2 over 1. And you see that pattern continues. Up 2 clicks over 1 click. Up 2 clicks over 1 click. So we would say the rise over run is 2 over 1. That can be simplified to just the number 2. This looks like a fraction. You could think of it as a ratio. Basically, though, when you see this stuff, you can treat it like a division. It literally looks like the division symbol. You got a number on top, the horizontal line, a number on bottom. So this means 2 divided by 1. 2 divided by 1 is 2. Anything divided by 1 is itself. So it just simplifies to being 2. Okay. And the idea of rise over run is that it could actually work, though, for bigger intervals. This one is pretty easy to see because I just went 1 click forward. But rise over run works even for a larger interval. Like, for example, let's do this one. How do you get this point down here, this first point? How does it move to get up here? So we want to do rise over run, meaning go up first. So we'd go up 1, 2, 3, 4, 5, 6 clicks up. Please notice, do not count every point. Count as you move the point. This is where I start, so I count 1 as I move. Don't count 1. Don't start your originating point here. Don't call that 1. That's technically 0. You count as you move. 1, 2, 3, 4, 5, 6. That's a vertical distance of 6. That's a rise of 6. Excuse my handwriting. Now, that landed up here. Now, how much does it run horizontally to reach the point? 1, 2, 3. That's 3 boxes, 3 clicks over. That runs 3. Okay, so if I put it in this format, rise over run, that would be 6 over 3. 6 over 3 is the slope, but we simplify it. You can treat this like a division. 6 divided by 3 is 2. The slope is still 2. I'm just trying to show you how you can get this a lot of different places and how this format of rise over run works. Okay. Okay. Now, before we move on, I want to go a little further here. We can really cover almost everything just with this graph. Let's go to this data table. Let me clean up my screen a little bit. You got notes on this stuff? Let me clean up here. I want to fill out this data table looking at some of the points that we see on the graph. Can you give me the coordinates of this first point? Technically, it's 0, 3. The x-axis is always horizontal. This is the y-axis. Remember, f of x is also known as y. They're the same thing. Remember? So this point is 0, 3. The next point over here looks like 1, 5. Do you see how I did that? This is at 1, 5. Now notice this is not rise over run anymore. The order is reversed. Don't get that mixed up. This is traditional coordinate points, which are x, comma, y, meaning horizontal, comma, vertical. Don't get it confused. It's slightly different than rise over run. I'm sorry. I wish I could have made them the same, but it actually wouldn't work. They have to be this way. The next one here, this appears to be 2, 7. X coordinate is 2, y coordinate is 7. And we'll do one more. That's the 3, 9. If you really want to nerd out, you might notice that these data points actually all fit the rule. 2 times the input plus 3. 2 times 0 is 0, plus 3 makes 3. Let's do the next one. 2 times 1 is 2, plus 3 makes 5, right? 2 times 1 is 2, plus 3 is 5. I should write this out. We're doing it kind of quickly. 2 times 2 over here, that's 4. Add the 3, that gets you 7. 2 times 3 is 6. Add the 3, you get 9. What if I put the number 10 into this function? Now, 10 is over here. That's going to be off the graph. I'm not able to draw the line. Here's the 10, but it's going to be way up there off the chart. Apply the rule. 2 times the input, that would make 20, plus 3 would make 23. This is sort of the beauty of linear functions. If you come to enjoy linear functions, this is something I enjoy. I enjoy the clarity of this. It all kind of works together. Now, sometimes when studying slope, you don't have a graph. Maybe you don't even have the equation. Maybe all you have is the data table. So this is another skill we have to have. Write this data table down. Pause the video if you need to. Write it down. Okay. Now, how do we find slope from the data table alone? Well, if you notice that the inputs are going up consecutively, like they are, 0, 1, 2, 3, how is the outputs moving? It's increasing by 2. It's increasing by 2. And it's increasing by 2. Since the inputs are going up by 1, the outputs are going up by 2. Therefore, the slope here is 2. The rate of change is 2. Write this down again. The rate of change is the slope. If you can find out how a function's outputs are changing, the outputs, that's what matters, the outputs, you can find the slope. These outputs are going up 2 for every one input. Therefore, the rate of change is 2. Now, it gets a little tricky. This is a higher level skill. But look at this last set of data points. What happens here? They're not consecutive anymore. I'm going to do this in my head. What's the difference between 9 and 23? If I subtract starting with the larger number, I'd find this is actually a distance of 14, a difference of 14. You can count it if you need to. You can subtract if you need to. You can trust me if you want. This is 14. Now, this is going up by, from 3 to 10, that's an increase of 7. So this is a little tricky, but there's a way to find the slope here. And the idea is you make a ratio of the change in output over the change in input. This is another way of finding the slope. So write this down. Here's another way of understanding slope. Slope is the change in output over the change in the input. How much does the output increase for every change in input? If you think about the shipping function we looked at, as the output goes up 20 cents, every time the output goes up 20 cents, the input went up 1 ounce. It kind of reverses the order of things, but come along for the ride. It works. So here, I would say the output has gone up 14. I'm looking at just these last 2 data points here. The output has gone up 14, and the input has gone up 7. Therefore, I have 14 over 7. Now, this is a ratio. You treat it like a division. Top divided by bottom. 14 divided by 7 is 2. That is the slope of 2. So even if your data points are not consecutive, it's easy when they're consecutive. 0, 1, 2, 3, boom, I see it's going up by 2s. Here, it's a little harder to see. But if you set it up carefully, this will get you the answer. The change in output over the change in input. 14 over 7 equals 2. All right. Let's practice this on another page. Same thing. All right, here we go right here. Tell me right now, what's the slope? What's the slope? You can see it in several different ways. So the first way I like to look at is it's the multiplier. But I'm looking right here. What's the multiplier? Is the slope x? No, the slope is not x. The slope is a number. The slope is the multiplier happening to x. Oh, but I don't see anything. I do. Do you see the invisible one? It's an invisible one. This happens a lot in math. Anytime you got a variable by itself, that x means 1x. It's invisible. You can't see it. Sorry, slope is 1 because the multiplier is 1. If we were going to actually run this function, technically, I mean, really, you would just add 5, right? X, just add 5. But technically, first you multiplied it by 1, and then you added 5. The slope is 1. But where else do I see the slope? Let's look at the graph. Here's a point, here's a point, here's a point, here's a point. For every click forward, how much does it rise? Well, I would say this rises 1 for every click forward. Rises 1 for every click forward. Rises 1 for every click forward. That's a slope of 1. And now here, let's plug some numbers in. If x is 0, well, I would add 5, and I would get an output of 5. That's 0, 5. That's this first point right here. That's 0, 5. Well, what if x was 1? Well, 1 plus 5 is 6. That's this next point. What if x, the input, was 2? Well, add 5, your output is 7. 2 to 7. That's here. So, as these consecutive inputs go up by 1, the outputs also go up by 1. Therefore, the slope is 1. And let's jump forward here. Let's pick, I don't know, this one right here. What point is that? Can you give me the coordinates of that point? It looks, if I look here closely, it looks like it's a horizontal value of 8 and a vertical value of 13. That's point 813. I'm going to put that into my graph here, 813, into my data table. Technically, if you think about it, if x is my input, 8, you add 5 to 8, you get 13. That checks out. But now, how could I find the slope maybe just between these points? From 2.7 to 8.13. This increases by 6. Can you see that? And this also increases by 6. So if we follow that format, I'll write it out again, which is change in output over change in input. You will see that this one, the output went up by 6 and the input went up by 6. Treat this as a division, a simplification. 6 divided by 6 is also 1. Lastly, you can see at the rise over run method. This is rise 1, run 1. But or like, for example, I don't know, let's keep this 813. I like that. And then let's go with this first point right here, this 0, 5. Let's do rise over run for this. So carefully count. I got to get all the way up to 13. 1, 2, 3, 4, 5, 6, 7, 8. That rose 8. That's a rise of 8. And now what's the run? 1, 2, 3, 4, 5, 6, 7, 8. Also 8. That is a run of 8. That is a run of 8. So if we think of it as rise, excuse my handwriting, over run, that's 8 over 8. Let's simplify that. 8 divided by 8. That's 1. So all of these different ways give us that same answer. The slope is 1. Lastly, please notice it's a positive 1 because if you read it from left to right, it's going up. Good. By the way, since we're here, the y-intercept starting amount would be 5. We see that right here because that's where this graph starts at 0. That's also this 5 right here in the rule. Let's move forward. Let's do another one. All right, here we go. Tell me, what is the slope? What's the slope? Did you say 3? It's 3. How did you know? Again, you can see right here, it's the multiplier. That's the easiest way if you have the rule. Let's look at the graph here, though. Can you find the slope of 3 on the graph? Can you find it? Well, let's mark this point right here, and then let's go up and look for the next clear point. These are kind of not unclear. They're kind of partway there, so I don't want to mess with that. Let's go with these nice, solid, clear distinctions, right? This is clearly a whole number right there, and I see another one up here. So tell me, how much is it rising for every click forward? It's going up 3 over 1, up 3 over 1, up 3 over 1. That's a slope of 3. What about this? Do a rise over run for me. Starting down here, I don't know, maybe they just gave you 2 points. If all they gave you was 2 points, you could still calculate slope by doing rise over run. I would say it rises 1, 2, 3, 4, 5, 6. That's a rise of 6. And the run is 1, 2. That's a rise of 2. So rise over run. You like my handwriting? I do. That is a rise of 6 and a run of 2. 6 divided by 2, simplify it, you get 3. Slope is 3. Now, sometimes this division might give you a decimal. That's okay. Sometimes we prefer to keep slopes as fractions. Sometimes it's better to keep it as an awkward fraction than a decimal, just because the fraction really lets you count it out. If I see it's 6 over 2, that means up 6 over 2, up 6 over 2. Lastly, over here, let's say we had some data points here. I don't know. Forget the graph. Forget the graph. I'm going to give you some numbers. They're so big, they won't fit on here. How about this? Let's do input 20 and input 30. These are not even on the graph. They won't fit. They're technically on the graph, but not on this page. So 3 times the input, that would be 3 times 20. That's 60. Plus 1, that makes 61. If I put 20 into this function, my output is 61. Now, how about for 30? 3 times this new input, 30. 3 times 30 is 90. Plus 1 is 91. So now I have 2 points right here. Let's do this by using that format. Change in output over change in input. All right, so if we look over here, the output is going up. I'm going to do this in my head. Feel free to subtract. Put the bigger number first, subtract. I can do it in my head. The answer is 30. That's an increase of 30. That is the change in output. Please make sure you're writing everything down. The more you write in your notebook, the more it'll stick in your mind. Now, we need the change in input. That's over here. Looks like the input is going up by 10. So this is 30 over 10. We want to simplify that by reducing it or dividing it. 30 divided by 10 is 3. So all these different ways give us the same result, positive 3 slope. It's positive because the line is increasing. Nice. Since we're here, you'll notice the y-intercept is 1. It's starting down here at 1, and it was right here in the rule also. Okay, we're doing great. Let's just keep practicing. Here's another one. Okay, what's different? This page now has some negatives, right? The graph is now all 4 quadrants, including the negatives. Negatives make everything harder. Sorry. If you're struggling with negatives, I do have some videos about that. You can check it out on the channel. Right here, tell me immediately, what's the slope? The slope is 2. You can see it right here. Slope is the multiplier. You can also see it if you look closely here. Pick any points that are clear. I could pick them all the way down here. Just don't really go for these halfways. Those can be kind of misleading. But anywhere where it's clearly on the line, right? I would say this is rising 2 for every click forward. 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 Slope is 2. We can still find it as a rise over run. We could find it as a rise over run anywhere on here. Just give me any 2 clear points. Negatives are fine. I don't care. Just be thorough. Here's one and here's one. For example, to get from here to here, how much does it rise? Rises 1, 2, 3, 4, 5, 6. That's a rise of 6. And a run of 1, 2, 3. A run of 3. So in that context, rise over run. We said the rise was 6 and the run is 3. We divide that, you get an answer 2. The slope is still 2. And again, what if there was no graph? Let's go back to the data table. What if, I'll do it again. What if I'll plug in 10 and 20. Here we go, 10 and 20 into the function. Okay, if the input is 10, this would be 2 times 10, that's 20, minus 3. 20 minus 3 is 17. Feel free to pause this and write that out if you need to. Now the next one, I do 2 times this input. 2 times 20 is 40. Take away the 3. 40 minus 3 is 37. Okay. And now we're going to look at this format for slope. Remember, slope is change in output over change in input. These are all different ways we find slope. So looking over here, I'm doing this math in my head. Feel free to write it down, write it out. This change in input here looks like it increased by 20. And over here, I'm sorry, I misspoke. That was the outputs. The change in outputs increased by 20. Here's the inputs. They're increasing by 10. So the change in output would be 20 over the change in input, 10. We get 20 over 10. Divide that. 20 divided by 10 is 2. Very nice, very nice. The slope here is 2. Since we're here, the y-intercept starting amount is actually at -3. I get that from right here in the rule itself. Over here, don't be confused. It's not starting down here. Technically, the graph goes off the page. When I say starting amount, I mean when the input is 0. That's why we call it the y-intercept. Right here on this y line, that's this point right here. This is the y-intercept because it's where the graph intercepts the y-axis. It's also, if you notice, it's when x is 0, this is the point on the graph when x is 0. When x is 0, the output is -3. That's this point here. That's a function technique. All right, how's it feel? Are we getting somewhere? Let's do one more right here. Tell me, what is the slope? First off, is the slope positive or negative? From left to right, this graph is going down. This is a negative slope. This line is decreasing. How much is it decreasing? It's going down 1 every time. Down 1, down 1, down 1, down 1. This is a slope of -1. If you look up here at the rule, do you see the -1? Sort of. I definitely see the negative, but this is that example of the invisible 1. Negative x means -1x. This is a slope of -1. If we were going to do a rise over run situation, I don't know, maybe from here to here, I would say the rise is -3. It's going down. It's dropping 3. It's not rising 3. It's coming down 3. You can consider that a negative rise. That's -3 is the rise. The run, however, is positive because I'm running to the right. We always go left to right. So this is down 3 over right. So from a rise over run perspective, this is -3 over 3. -3 over 3. This simplifies to final answer -1. -3 divided by 3 is -1. The slope is -1. We could also find this in the data table if we picked a few points. For example, I'll just give you some points here. Let's say -4 and 5. -4 and 5 is on the graph. Technically, it's -x. That would flip this negative to a +4. Add 1, you get the 5. And I'll do a point over here. Let's do 4, -3. Okay, so I just pulled these off the graph. Let me clean this up a little bit. These 2 points, I pulled them off the graph. -4, 5 was here. 4, -3 is here. This also fits the rule. It's kind of tricky mathematically, but -x, meaning flip this to -4, and then add 1, making -3. You got to trust me on that. This is a negative scales. If this throws you off, just come along for the ride. Don't let this ruin your experience today. This is kind of tricky negatives. I'm doing it in my head for the sake of time. All right, this one is going, and if you think about it from this perspective, it's going, that's a difference of 8. From 5 to -3 is 8. But this one is the difference of -8. You might reverse them. It's a little tricky, but you have to identify and realize this one is going down. This number has decreased. This number has increased. Either way, they're moving in opposite directions. So that idea of change in output over change in input, that concept here, you got to realize one of those numbers is negative. You could actually do it either way. It kind of doesn't matter to me. You could make it -8 over 8, or you could make it 8 over -8. Don't let this confuse you. The result will be -1 either way. That's probably the hardest method. This method here of finding the change in output, change in input, Once you got these negatives in here, it can be a little confusing and a little risky, but it is still valid if you're confident with negatives. There's also a formula for it called the slope formula, which we will look at later on. Any questions? Leave a comment in the chat. If you have any questions, leave a comment down below. And please take a minute. If you like what you're seeing, if you like this video, if you're learning, please like the video. Please subscribe to the channel. And if you can, send this video to someone who could use some help with this material. Send this video to someone who would get something out of this. It's word of mouth recommendations like that that help keep my channel growing, and I appreciate you all for it. So here we are going to close out today with this information. I'll have a second video following up with some more advanced applications. Here we go. Copy this in your notebook. Let's just let all this settle down. Slope of a line, the slope of a linear function. The definitions. Visually, slope is a measure of steepness. A large slope is a steeper line. A smaller slope is a more less steep line. A slope of 0 is a flat line. Flat. The floor should be a slope of 0. Although I've been in some apartments where my floor was definitely not a slope of 0. It was slanted. It was slanted. Things would roll around in that crooked floor. Okay. But ideally, the floor to your place should be 0, nice and flat. Slope is a measure of steepness. The higher the slope, the steeper the line. A negative slope means you're going downhill. That's visually. Mathematically, slope is the rate of change for a linear function. In a linear function, slope is the multiplier. Slope is the rate of change for a linear function. If it costs 20 cents for every additional ounce, the slope is 20 cents. If it costs $2.90 for a subway ride in New York City, if I graph that chart, if I graph those prices, the slope is $2.90 because that's the rate of change. For every extra swipe, you pay another $2.90. If gasoline is $3.50 per gallon, if you make a graph of the pricing, the slope will be $3.50 because for every additional gallon you buy, you pay another $3.50. The rate of change is $3.50. The slope is $3.50. Slope is the rate of change. As you've seen, you can ask yourself with a graph, how much does it go up for every click forward? Slope is known as rise over run, which is rise slash run, which is rise divided by run, which is sometimes like this, rise over run. Okay. This means vertical change divided by horizontal change. How much did it change vertically compared to how much did it change horizontally? Rise over run. This is also the change in the y value over the change in the x value. This is that concept we talked about a minute ago. This is change in output over change in input. Rise over run is actually just determining how much did the output change compared to how much did the input change. Rise over run is the output difference compared to the input difference. This means subtracting to find the difference in y values. It's a little technicality. Come along. Subtracting to find the difference in y values over subtracting to find the difference in x values. Remember when we did it in the data table and I said I had to kind of count or subtract? Okay, well, the outputs went up by 20 and the inputs went up by 10. We were subtracting, essentially subtracting in our head to find the difference. This is the slope formula. This is new for today. This is a big deal. It's kind of hard. It's kind of famous. This is the slope formula. Slope formula is written this way: y2 minus y1 over x2 minus x1. This is just systematically making you subtract to find the difference in the y's. That means find the difference in the outputs. That means find the vertical change. This y2 minus y1 is mathematically counting the rise. If it rises 3, when you do the math, you're going to have a 3 on top here. And then the run is the difference in the x values. from x2 minus x1. This is the slope formula. You notice they use the letter M again from the French montreur for mountain, as in slope. It's also the multiplier in a function. Okay, in this context, x1 and y1 are the coordinates of a point, the first point in the line. x2 and y2 are coordinates of the second point in the line. You notice these are not exponents. This is not second power. No, it's just a label. This is the second y minus the first y, and the second x minus the first x. It's that one minus that one, and then this one minus that one. I've also seen this where it's reversed. They put the 1 first. It's y1 minus y2, x1 minus x2. Totally the same. I don't even care. I do it that way all the time. I don't care if you put the 2 first or the 1 first. It just means take one y value minus the other, take one x value minus the other. We're going to study this formula as well as some more challenging applications of the slope formula in the next video, Slope Formula Part 2. I want to thank you for watching. Please, once again, any questions, leave them in the comments and I'll try to respond to all of you. And please like and subscribe, share this video with anyone who you think would get something out of it. It's word of mouth recommendations like that that help grow the channel. I appreciate you all. Good luck. Take your time. Write in your notebook. Practice makes perfect. Repetition is the key. Thank you very much. I'll see you next time.